Good Monday, everybody. Hope everybody had a nice weekend and nice job last Thursday on your test. We are going to start a mixed unit on graphing. We were supposed to be doing graphing basically for the last 5 weeks, mixed in with all the other units. But we were kind of hoping to be back in school and be able to do this in person. So we'll do the best we can. We'll figure this out as we go. So, mixed unit. We have all different types of graphing here in this unit. So make sure you take good notes. Use your notebook to jot things down in, print stuff off, keep it with you so that you can use it in the future. So today, what we're going to be working on is finding features for rational functions. So this is the graph of irrational functions. And so I just want to show you a few things of the stuff that you're going to be finding. So this graph is one graph where the blue line here goes on up to infinity, and then eventually it just stops and starts back over. How that works, only the math really knows. But it picks back up. And so essentially, this graph goes up forever, left forever, right forever, and down forever. However, it doesn't connect in the middle. It has what's called a vertical asymptote that falls right down through the middle of the graph. So that right there is called a vertical asymptote. And that's one of the features that we're going to be finding today. One of the other features that we'll be finding is called a horizontal asymptote. So very similarly, right through the middle of the graph, right through here, is a horizontal asymptote. And we'll be looking for that as well today. In addition to those, right here, that point, that is your y-intercept. That's another thing we're going to be looking at today. If you look at this blue graph, you'll notice that the blue graph doesn't ever touch the x-axis. No x-intercepts along this graph. But x-intercepts are something that we will be looking at as well today. Looking for the x-intercepts of this graph, as well as something called a hole. A hole would literally be a hole in the graph, where this line would not be going through it at all. It would just come up to the hole, it would stop, jump over, and continue going. So those are the 5 things that we're going to be looking at today, the features of a rational function. This is basically, had we been in class, I would have given you very detailed notes on holes, asymptotes, and intercepts. So this is just a little cheat sheet that you might print out, keep in your notebook, write it down, keep this handy, because this is really what you want when you're going and finding all these little features. So the first thing that I do when we're finding these features is factor the top. Our x-intercepts come from factoring the top. And so, yes, you're going to have to remember all those different ways of factoring. When we solve that factoring, you'll get the x-intercept. And so that x value is how we're going to answer the question. The second thing that I'll go through is finding the y-intercept, which is dividing the constants. So at the end of each polynomial, you have that number that doesn't have a variable on it. Remember, that's the constant. And so that's where we're going to get our y-intercept from. After factoring both the top and the bottom, we'll find our holes. If we factor our top and our bottom and something cancels, then we have a hole. we'll substitute that back into the problem. We'll figure out what our hole is, and we'll move along. If nothing cancels, then you don't have a hole. But the big question there is, when I factor the top and the bottom, does anything cancel? And so we've been through rational functions. This is probably one of the last things that we did prior to leaving for our coronication, is we did factoring of the rational functions. The fourth thing that we'll do is work on our vertical asymptote. Okay, so over to the side, I kind of wrote that out, but briefly, VA is going to be vertical asymptote. So after factoring the bottom, which we would have already done, after factoring the bottom, when we solve for x, that's going to be our vertical asymptote. The toughest part here is the horizontal asymptote. And what we have to do is we have to look at the degree, which are the exponents, of the top and the bottom of the fraction. And we have to compare them. Okay? Are the degrees equal, meaning that the exponent on the highest exponent on the top is the same as the bottom? Is the bottom exponent bigger, or is the top exponent bigger? And so as we are discovering our horizontal asymptotes, we're going to talk about these equal top bigger and bottom bigger situations. Okay? So keep these notes close by, handy, so that as we're going through the delta math problems, because that's what I'm going to do, is I'm going to show you, like, this is a delta math problem. This is what your homework is going to look like. So keep the notes, this little cheat sheet, nearby so that you can refer to it, because I'll bring it in and show it to you as we move along. All right, so let's work this problem. That is a delta math problem. It's going to look very similar to what you guys will be doing for homework. Please notice you do have the no option, so no horizontal, vertical, no x-intercept, no holes, okay? You do have those options. So in the event that we don't have something or something doesn't work out for us, we can click on that, okay? So first thing I'm going to find, x-intercept. So the first thing we're going to do is factor the top. And we're going to solve that. It'll give us our x-intercepts. So please note that the first thing I'm finding is actually in the middle of the answer. So the x-intercept. So I'm going to factor the top. And that's going to be a GCF factoring. So the negative 5x and the 15 have a negative 5 that will divide into both of them. So that's going to turn out to be x minus 3. So since the top has a degree of 1, there's only one answer that we get from the top. And as we, let's see, we'll go back to the notes. All right, so we factor the top, now we'll solve. So there's only one thing we can solve for. It's this x minus 3. So right here, x equals 3 will be our x-intercept right here. So we're going to put a 3 in for the x-intercept. And so notice that it already has it set up as an ordered pair for you. So you just have to take that 3 and plug it down here into the x-intercept. So that was step 1, was factor the top and solve. Now we'll find our y-intercept by dividing the constants. The constants are right here. These are your constants. When we divide 15 by negative 3, you get negative 5, and that's going to be your y-intercept. So far, kind of moving through this pretty quickly. Okay, third, we'll find the hole. Does it have a hole? Well, in order to find the hole, we have to factor the top and the bottom. We already have the top factored, so now we'll factor the bottom. The bottom is a trinomial, so we'll have two sets of parentheses. X, we'll have a 1 and a 3. And you'll notice that the sign is negative here. So that's going to make the 3 carry the sign. and we get an x plus 1 on the other side. So we factor the bottom. So we're finding the whole. Factor the top and the bottom. Did anything cancel? Yes. If you'll notice, the x minus 3 and the x minus 3, these guys will cancel right here. All right, so I'm going to come down here and do the work. So since these cancel, right, x equals 3 is going to be the location as to where the hole is. So that hole, that x value right here, is going to come down to the hole. We'll put the 3 in there. And then the rest of the hole direction says substitute. So we'll take what is remaining. So in the rest of the problem, this x minus 3 and this x minus 3, they're gone. They're gone for the remainder of the problem. So what remains from our problem is negative 5 over x plus 1. That's what remains in the problem after the x minus 3's cancel. So we're now going to substitute this 3 into the problem. And so when we do that, we substitute that negative 3 in. We get negative 5 over negative 3 plus 1. And that gives us negative 5 over negative 2, which will come down here as 5 halves. Positive 5 halves. So that's the whole. And that's one of the trickier parts to the problem, is the whole. All right, so just a reminder, as we're going through this, this is what remains in the problem. This is our new problem. This negative 5, negative 5 over x plus 1. That is where we are. This is what we're working on in the problem now. All right, so we have our x-intercept, our y-intercept, and our whole taken care of. So we'll go down to our vertical asymptote. Factor the bottom. Okay, well, we have the bottom factored. We have it canceled to the point where we're right here at x plus 1. So if we solve this bottom for 0, then we'll get x equals negative 1. And that is our vertical asymptote, negative 1. So we took x plus 1, set it equal to 0, we solved that by subtracting 1, and you get x equals negative 1. So that becomes the vertical asymptote. And finally, we're on our horizontal asymptote, which we now have to look at the remaining degrees in the problem. So since this is our problem, this is what remains. You have a 0 degree on the top and a 1 degree on the bottom. So we get to compare. Are the degrees equal to each other? Is the bottom bigger? Or is the top bigger? Well, let's see. The top is 0, the bottom is 1. So that's going to tell me that the bottom is bigger, and we have a y equals 0 asymptote. So our final answer for the horizontal is 0. Okay, so those are the 5 answers that we need to get for this problem. And for those of you wanting to know, this problem is this graph. So when you look at this, horizontal asymptote, y equals 0, that is the x-axis. The vertical asymptote at negative 1, that's this reddish line coming down through here. The x-intercept, it's not showing the x-intercept. Oh, it doesn't have an x-intercept. I'm sorry. The so we have our y-intercept at 0, -5, and we have a hole here at 3 5/2. So what you can't see is that there is actually a hole, 1, 2, 3. There's a hole right there that you can't actually see. There's a hole right here at 3 5/2 that you actually can't see. All right, so that's how we do the problem. So we'll keep going through that, do a couple more problems, couple more examples, and then I highly suggest that you guys ask questions. Okay? All right, so let's factor. We had -3 on the top, followed by an x minus 5. On the bottom, we have an x and an x minus 5. So since something cancels, we got cancellation here. We're going to have a hole, so that gives us a 5 for the x value, because the 5 value is what makes this become 0. If you put a 5 right there, and this becomes 0. So if you solve this for 0, it'll give you a 5. That leaves us with the problem -3 over x. This is the remaining problem, and this is what we will find everything else with. Okay, so we're going to take that 5. So -3 over 5, because we're going to take this 5, plug it back into the problem right here, and that gives us -3 over 5. -3 over 5. So that's our hole. Whoops. All right, so everything else is going to come from this part of the problem right there. Let's find my cheat sheet. Okay. All right, so if we take the top and we try to solve, you can't solve this because it has no x value. So that is for our x-intercept. We don't have an x-intercept, so we will answer it with no x-intercept. The bottom, y-intercepts. Divide the constants. Let's see. The constant on the bottom is 0. So if you take -3, this is like plus 0. So if you take -3 and you divide it by 0, it's undefined. So we actually have no y-intercept as well. So there's nothing here, there's nothing here. So don't answer those. So we have our x-intercept, our y-intercept, we've done our hole. Now we're on to our vertical asymptote. Factor the bottom and solve for x. The bottom is already factored. If you take x plus 0 and set it equal to 0, then you'll find that your answer there is 0. So if we took x and we set it equal to 0, this right here, then you simply just get 0. So the vertical asymptote becomes 0. And finally, we get to our horizontal asymptote. We look at the degrees. Degree on the top is 0. Degree on the bottom is 1. Therefore, the bottom is bigger, and the y-intercept is 0. I'm sorry, the horizontal asymptote is 0. So we'll put a 0 in for that as well. So there are all the features for that problem. So we'll take a look at our final example here. Don't ever get too afraid. They're all very, very basic problems. We will factor. First thing we want to do is factor, see if there's any holes. So we can pull out a -3x on the top, which would leave us with x plus 4, and then a 5x squared on the bottom, because it's not going to factor. So you want to factor out the problem first. That's the very first thing you want to do. Now at this point, nothing cancels. So if nothing cancels, we do not have a whole. So don't answer a whole on that. The next thing we want to go to is the x-intercept. X-intercept comes from solving. Where's the x-intercept? 3x, negative 3x equals 0, and x plus 4 equals 0. So it looks like we have two x-intercepts on this problem. So we'll have x equals 0 and x equals negative 4. So I'm going to use the negative 4 as the answer there. That's interesting because you have two x-intercepts, but it's not allowing you to put two answers. So in that case, use the actual number, because I'm pretty sure what's going to end up happening is, we're not going to have a y-intercept, so you can actually have the x-intercept as well. I'll show you that in a second. So the next thing we're doing is that y-intercept. And so if we take a look at the problem, you have 0 and 0 for your constants. And if you divide 0 by 0, you don't get anything. It's non-existent. So we actually don't have a y-intercept. So if you don't have a y-intercept, in other words, then this 0, 0 can't occur either. So don't answer that. A vertical asymptote. Vertical asymptote comes from the factoring the bottom and solving for x. So if we take the bottom, which is already factored, the bottom, 5x squared equals 0, then and you solve this, you'll get x equals 0. So if you divide by 5 and take the square root, then this will end up as 0 as well. So we get 0 for the for the vertical asymptote. Another reason why we have no y-intercept and you don't have this x equals 0 as an x-intercept either, because it doesn't exist on that line. And finally, for the horizontal asymptote, we got to check out the degrees. There's nothing canceled here on the problem. The degree on the top is 2. The degree on the bottom is 2. So our degrees are equal. We have equal degrees. Okay. So if we have equal degrees, then we're going to divide the leading coefficients. And that gives us our horizontal asymptote. So the leading coefficients are negative 3 and negative 5. Those are your leading coefficients. And so if you divide those, you just keep that fraction. Get negative 3 over 5 becomes the horizontal asymptote for that problem. And that's the 5 features for that problem. So that's 3 different examples of finding the features of rational expressions. I hope that you guys will ask questions. The Delta Math assignment has 10 questions like we just did. Each question has, or each problem has 5 questions. X-intercept, y-intercept, vertical asymptote, horizontal asymptote, and holes. Find your holes first. Okay? Please find the holes first. That'll set up the rest of the problem. This is basically a 3-week unit. The test we're going to have is on May 7th. Somewhere in the middle of between now and May 7th, we'll have a quiz. Help get your averages up a little bit. And then don't forget, I will be available for you from 11 to 2. I don't have that many pre-calculus kids anymore, so that'll give you guys about 3 hours to sneak in and ask some questions. Good luck. Hope you guys have a great day.